I'm Lukasz, and I'd like to talk to you about this library I wrote, Voyager. What Voyager can do, it can help you turn the requirements into configuration file for your app and navigation. Before we start, though, probably you might wonder who I am. So this is a company I work for. We're based in Berlin, Germany, awesome city, and we do photo app. You can upload your pictures there and share, and then maybe sell even. Thing work? No? Come on. All right. So I'm gonna start with sample app. This way I can better describe how Voyager API works. And after that, we're gonna jump to more advanced topics. And we're gonna start our sample app by defining some requirements for it. And it's gonna be pretty boring screen that doesn't do much. It has, maybe I'll stay here. It has a hello world title and a button with a plus icon. And that button takes you to a different screen, which is also has a separate ticket for it. We should just display a big, very big icon, and that's pretty much it. Now, if we go to next slide and group these two tickets together, we get ourselves high-level overview of requirements for our app. And I've put it on purpose as bullet lists because this can be easily turned to a format that's understandable to computers. And this is also where Voyager kicks in, and it can help you parse this information for your app. Okay. Yeah, I'm gonna use spacebar, I guess. So how this file is organized, on the top you have paths, which are addresses for your screens, and then you underneath you describe what these screens are made of. So you have plugin nodes on the left, and on the right the value description of what we are solving here. There is also one extra thing, which is parameter interpolation. Meaning you can take any parameter from path and just pass it down to the config. I'm gonna use these terms as synonyms because in terms of Voyager they mean practically the same. Now speaking about architecture, the central piece is a router, and any router needs a map. And that map, in our case, is a YAML file. And once you have a map, we resolve part of the map, that subsection which describes our screen. That is a config, and config contains all this information. No, that's not gonna work. So we pass the title. What we do here, we take the title and we put it in Voyager map. And by default, this in YAML was a string, so it's going to be in Voyager map string as well. But in other cases, you might want to do something else. So for icon, it's a plus, which is a text, but it's kind of useless once you start to putting your widgets together. So it's better to turn it to icon on the widget icon. And this is what plugin can help you achieve. speaking of which, here's how we could implement one of these plugins. So we start by extending router object plugin, and then we specify what type it is and what's like the icon node we're gonna handle. Up next, we need to implement the build object method, and that helps us to return that object we want to have. In this case, we get a dynamic config argument, which is going to be a plus. So we need to turn it to icon instance, and for that we have like some icon helper method. Any library has boilerplate, so does Voyager. To get you started, we need a few lines of code. We need some place where we load our map from. It can be JSON file, it can be from internet or from string, anything you want. And then we define which plugins handle information in our map. So we need a widget plugin. As you might have noticed, we have home widget written in text. So we need some way of turning that into a Flutter component. We're also going to use icon plugin we've just implemented. Having paths and plugins, we can now start using a router in our app. And here's how you can do it. So you embed essentially any path anywhere amongst your widgets. You pass a path and the router. You can even omit the router and use solely path. To do that, you need to go to next slide. Yeah, and provide router above your material app. No, yeah, and this will expose router to any widget you're gonna create later on. And speaking of material app or Cupertino app, this is how you can get integrated with Voyager. So you use Voyager widget as your entry point with path you want to resolve to, and this tiny little bit helps you have the navigation sorted, which using the Navigator API. Oh no. Okay. So you can use standard Flutter API to navigate between the screens. And speaking about dependency injection, so what Voyager does internally is using provider, and all this information you had in your configuration map will now be displayed to you. So you have Voyager widget, you provide it with path. Provide it with path, you give it a config. That config creates an instance of Voyager, and this instance is also exposed to home widget via provider. And this is how you'd write your normal UI code, so you can access Voyager instance, and then you can just populate all the UI elements with Voyager elements. And here icon will already be an icon instance. Moving up next, we'll talk a bit more about Cogeneration and how it can help do this better. A prerequisite to using Cogeneration is having a type per path, lowercase snake case, and this allows Cogenerator to give meaningful names to values and fields it generates. You start the project by running this command, and it will start watching for file changes. in the navigation map. Or you can also, if you're in CI environment, just run it once. And what it will do, first time you run it, it will generate you a file to configure this Cogeneration. And what you have in this file, like a location where your navigation map is, and target to which we're gonna output Dart code. You can use the navigation Dart as well if you include navigation map within triple quoted strings. All right, and this is what will be generated for you. Strong type paths and strong types per every screen path. And why is it good? So imagine you had like this path and it's like manually typed, so it's error prone. I mean, usually you would like define constant value, but you don't have to do it anymore. You can just like rely on Cogeneration here. Triangles are my favorite shape. Well, I lied. It's more about pyramids, testing pyramids in Flutter. And here is where Voyager can excel. So you might wonder what has Cogeneration to do with it. But essentially, if you supply this line, you'll get yourself this file, this class. And this class is abstract and has two abstract methods you need to implement because you had two paths in your YML file. And as you're gonna add more methods to this navigation map, this class will grow, meaning you have to implement more and more. What you are implementing are test scenarios per each screen. And here you also have like a helper method that can supports you, meaning you already have like an argument you need to pass and the widget tester to assert things about your UI. Once you have a concrete implementation of your scenarios class, you execute them within your tests. And just to give you an example, the app that's a sample app coming with Voyager library, by having one scenario implemented per one path, and there are like two paths, so two scenarios, the coverage jumped to 70%, which is pretty good, I think. There is, however, one big problem with navigation map. It's all text. So if you rely on compiler, it will give you safety. And with navigation map, you just type anything and you are prone to type errors. To mitigate this problem, a schema was introduced. And you start specifying it per each plugin node. You start with, let's start with an icon. So we say like what type is the input. We use JSON draft v7 schema in shape of YML. And then we use say what it is on the Dart side, meaning it's an icon type and where it's coming from. And if we do it for icon, we also need to do it for all the other plugin nodes. And now if you run Cogeneration again, you're gonna get a feedback if your schema is all good, or maybe you use something you should not. Also, like, depends how good your schema is. And there are changes. This brings to the code, the widget code. So now you can use, you can rely more on generated methods. So you can start using generated Voyager provider, which still uses provider underneath. It just does smart casting. And all these fields now become strong typed. And I think this is like pretty good. how it's done, the Voyager instance is extending and adding extra methods, and the router does not know about it by default, so we have to supply a factory that will tell to use this, and this factory is generated as well, but just please remember to do that. Last part of Cogeneration is plugin stub. It's a little tiny thing, but it helps you reduce 2 lines of code in your plugin implementation. So in our icon plugin, this would mean we can change now this to plugin stub and get rid of this part. If you liked what you've seen so far, the package is available at pub.dev. And now I'd like to talk about some more advanced things. As we all know, Widget is a lie, and Voyager is Widget Router, so it's a lie as well. Anyway, going back to our initial example, imagine you want to reuse the fab button across different screens. So in Voyager, you can actually map it to a separate path. And now this makes your thing more reusable. And if you don't believe me, it actually works. You can check out this address online. It does look a bit ridiculous. Just proving point here. But let's not stop there. We need to go deeper on this. This is all text. So this means you can send it over the internet. So maybe you want to run some A/B tests and check maybe hard works better, converts better. And this is relatively easy. So all you need to do is turn this text into instance of router path and then just push it to router at the runtime. You can also, like, if it's text, like change it when your app starts. Flutter 1.2 introduced navigation with arguments, and this is useful when you need to pass something to another path, like service database that you can reference by ID. And this is quite important in a lot of cases, so Voyager also mirrors this API. What is happening? Whoops. Sorry about this. Not the best day today. Anyway, regardless how you pass the argument to the next path, you can always retrieve it later in Voyager context. Just unwrap the value from Voyager argument. And this brings me to something stranger. Oh, imagine you have a shoe. And now with this, you can map shoe to any path or class shoe. And as we know, Voyager is good at mapping paths to widgets. So essentially, we can turn an object of shoe into a widget without explicitly referencing the shoe widget. But we shouldn't stop there. We can map any class to any widget. And if we do this, maybe let's have a list of different items and automatically map it to a list of different widgets. Here's how you could implement it using Flutter and Voyager. So we start by supplying what's like the item length, and then we supply a builder for each item. We get item based on the index, and when we provide it to Voyager widget, path is based on runtime type, and as an argument, we pass the item. If this approach is like interesting to you, there is experimental package, an add-on, so please feel free to check it out. And I guess the last example is about block. Has anyone here heard about block? All right, quite some hands. So block is a state management for Flutter. And I'm going to start here with another sample app, but this one is by Felix Angelov, because the plugin is for his library. And this block, this sample app defines two blocks, so they handle states of the counter or of the team. The counter block, what it does, it listens to events dispatched from the UI, and in return propagates a new state. So the counter goes up and then goes down, and team block is basically a toggling between light and dark team. Now what you can do with Voyager is specify what kind of blocks you want to use, how many of them, and supply an initial state for them. So what you need to do is use block plugin builder and specify mappings for the text values in the code. It's very similar to widget plugin builder. Additionally, it also has repo. So repo lets you reference other blocks. When you have context, context is a router context, so it has parameters of the path. Config in this will be number 42. So we supply this to counter block and we create instance. I had to modify counter block to accept an initial state as an argument. So here's how you can do this. And in the widget space, you can get a block repository and find any block by type. And this is available as well on pub.dev. So if you're a block fan, check it out. And I'm slowly getting to the end, so I'd like to recap. Sorry about like all these technical problems. So your navigation map is a text file, meaning you can and also readable format, so anyone, like newcomers or veterans, can like take a look and, oh, there are like these paths, and there are like these widgets going to these paths, and oh, there are like these logical blocks. So it's like one space where you can easily find where is what. And since if you treat like this map as requirements, it will stay in your Git repository. So all the changes are trackable across GitHub branches, and that's not something like you can do with Jira or any other tracking system, because once you implement a ticket, usually after some time it gets outdated or obsolete, so you never look back. Here you do. This is given kind of for free because it's a router, so it's just doing its job. And this is what I like to highlight, because it's all text, so you can send it over the internet. And if you pair it with Firebase remote config, it makes it trivial to send like bits that you want to change in your app. Pair it with some A/B test, and you can easily run a test. without actually changing any line of the code. So, I mean, how many of you have like AB flags in your code somewhere that were never removed after a test is done? Like, okay, maybe everyone removes them, not me. Well, anyway, so it's like another thing that you don't have to have feature flags anymore, you can have feature maps. And yeah, that's pretty much it. Thank you so much for coming.